Good morning. We are students from WYSII WYSII School. We would like to present our project. The title is A Novel Method for Producing Activated Carbon with Improved CO₂ Capture Efficiency. This slide shows the topics for my presentation. I will start with introduction. Global warming, which causes severe climate change, is due principally to the accumulation of greenhouse gases, of which the major gas is carbon dioxide. Power plants and industries burning fossil fuels are the major sources of CO₂ emission. As a result, the capture and utilization of carbon dioxide are becoming increasingly urgent. Presently, the use of solid adsorbents such as activated carbon for CO₂ capture by absorption has become an interesting choice due to its low adsorbent cost, process simplicity, and low energy consumption. Conventionally, activated carbon can be produced by physical activation using CO₂ or steam, but the efficiency of CO₂ capture are quite low. In this project, we propose a novel method called OTA method to increase the adsorption capacity, which consists of 3 consecutive steps. Step 1. Oxidizing an initial low burn of activated carbon with air or oxygen to create additional oxygen functional groups on the carbon surface. Step 2. Thermal treatment at a high temperature in an inert gas, giving rise to an increase in number of reaction active sites caused by bond disruption. Step 3. Activating the resulting carbon by carbon dioxide carbon CO₂ gasification to create more microspores. This is our objective. So our objectives are 1. To study the effectiveness of OTA preparation method in increasing the porous property of activated carbon. 2. To investigate CO₂ adsorption capacity in a fixed bed of derived AC.
This is the theory of the fixed bed absorption. The absorption dynamic of continuous fixed bed operation can be assessed from a vector curve, a plot of ratio C and C0 vs time, as shown in the figure. The characteristic parameter of the vector curve is the vector time or TB, which is defined as the time at which the concentration ratio C and C0 is equal to 0.05. The absorption capacity at TB or TB can be calculated from the vector curve by the following equation, where C is the outlet concentration of the adsorbate or CO₂. CO₂ is the unit concentration of the adsorbate. W is the rate of absorbent or AC, and Q is the volumic flow rate or the phase stream. Is a CO₂ and N2. The original activated carbon which we prepared from Corona shell was parched and was designed AC. The equipment used were 2 furnace, BET surface instrument, FTIR, and CO₂ absorption test column gas analyzer. For the OTA method, first step, the original activated carbon AC was oxidized. Second step, heating other into atmosphere. Final step, the resulting activated carbon was reactivated with CO₂. The activated carbon prepared by this OTA method was designed as AC OTA. For the conventional physical activation method, the original activated carbon was activated in CO₂. The activated carbon sample obtained by design at ACP. CO₂ absorption was carried out in the acrylic column packed with the prepared activated carbon. Feed gas was introduced into the column from the bottom, and exit concentration of CO₂ was then recorded as a function of time using a gas analyzer. The collected data between the CO₂ concentration at the column exit and the ovulation time were used to plot the vector curves. This is the result part. The carbon prepared by the OTA method, sample AC OTA, had higher amount of surface area, total pore volume, micropore volume, and mesopore volume as compared to ACP and AC samples, indicating that the OTA method could enlarge the smaller micropores by the gasification reaction. All carbon samples show similar FTIR spectral pattern. In addition, considering the intensity of FTIR major peaks, the amount of the surface functional groups in AC OTA is highest.
The breakthrough curve shifts to the right direction with the increasing porous property of the activated carbon. ACOTA is more than ACP and more than AC. Activated carbon produced from the OTA method provide higher CO2 capture capacity than those of AC and ACP by 42.3 and 24.7% respectively. The mechanism to enhance both development in activated carbon prepared by the OTA method, ACOTA, is shown in the figure. First step, air oxidation creates functional groups. Second step, heating of oxidized carbon will result in bond disruption of the functional groups, thus giving rise to the increased reactivity of micropore. Finally, the reactivation step creates new mesopore by the enlargement of original micropore as well as the formation of new micropores. Next is our conclusion. The activated carbon prepared by the OTA method has higher surface area, total pore volume, micropore volume, comparable basal pore volume, and the largest average pore volume as compared to AC and ACP samples. 2. Absorption capacity of carbon dioxide in a fixed bed of ACOTA carbon provide higher CO2 capacity by 42.3 and 24.7% as compared to that of the AC and ACP respectively. The project has made a significant contribution to more efficient capture of carbon dioxide from flue gases using activated carbon synthesis by the effective technique known as the OTA methods. This is our acknowledgement and our references. Thank you for your attention.